You just finished up 2 years at OpenAI, working on the theoretical foundations of AI safety. Did you solve it? And how come you finished working there?
A lot of my former coworkers have now left. The super alignment team that I was part of no longer exists. It has been dissolved. Sam Altman has restructured OpenAI to be a fully for-profit company.
How do you feel about that?
Well,
You've worked in quantum computing for over 20 years. You actually helped in 2019 Google's achievement of quantum supremacy.
what they did understand was that China was doing something in quantum and that the US had to beat China in the race for quantum. If only one person had a scalable quantum computer and no one else did, then that person could get very rich mining Bitcoin.
I'd love to get your status report on the state of academia.
It has been a stressful time for academia. You know, we've seen universities basically taken over. Some people will say, you are not allowed to mention anything about existential risk. That is all science fiction, and that is all distracting us from the real harms of AI, which are all about
What differentiates humans from machines fundamentally?
one way or the other. We're going to find out.
All right, Scott, welcome to the Win-Win podcast.
Thank you. It's great to be here.
Yeah. To start with, you just finished up 2 years at OpenAI.
Yes.
Working on the theoretical foundations of AI safety. So I guess the first question, at least the most obvious one it feels to me, is did you solve it? And how come you finished working there now?
Well, they invited me there in 2022 for a 1-year leave, sabbatical sort of, right? I have a day job, right? I'm a computer science professor at UT Austin, and I was skeptical when they came to me because I've spent most of my career doing quantum computing, right? I did study AI in grad school, but that was back in like 2000, right? Or like the Stone Age compared to where AI is now. And so I was skeptical that I would have much to do, and also OpenAI is in San Francisco, my family is in Austin, but they said, no, we want a theorist to think about, how to help make AI safe. We think it involves computational complexity, which I do know something about. And you can do it mostly remotely from Austin, just stay with your family and your research group. So they made it impossible to say no, basically. And that this was Ilya Sutskever and Jan Leike mostly who brought me in. So it was supposed to be 1 year. I then extended it for a second year. And it so happens that, during the 2 years I was there, first of all, they were, what a historic time for AI it was, right? And I feel privileged even just to have been a fly on the wall, right? Even just to have witnessed, from the inside, some of the things that happened in the last 2 years. But it was also a period, as most people know, of enormous upheaval within OpenAI.
So you've extended after 1 year prior to all of the drama starting, with all of the super alignment team still existing at the time, right?
Yeah.
Is that the reason why you didn't extend a second time as well?
No, it was never supposed to be more than 2 years. When you're an academic, there's sort of a limit of 2 years that you can go on leave without negotiating
Right.
some kind of special deal. And and the truth is, I wanted to get back to teaching. I run the Quantum Information Center at UT Austin, and if I want this to be a great place for quantum information, then at some point I have to, show up and teach and so forth. So 2 years was actually longer than I had planned.
So, I'd love to get more into some of the cultural dynamics going on behind the scenes a bit later on, though. Beforehand, I'd love to understand a bit more what the type of problems that you're actually trying to tackle.
Yeah.
there. What are the frameworks you're looking at? Because as you say, you were approaching it from a theoretical standpoint. If you could sort of talk us through as best you can in as semi-layman terms, the types of approaches you were thinking about.
Yeah. So I should say at the outset, I did not succeed at reducing, the problem of aligning AI with human values to a math problem.
Damn.
I'm not sure that I'm not sure that it can be reduced. And it was very funny for me because for a year I would talk every week to Ilya Sutskever about my progress on different AI safety problems. Such as watermarking the outputs of language models, which is maybe the most concrete thing I was able to make progress on. And Ilya would say, okay, yeah, that's great, Scott. You should keep working on that. But what I really want to know is what is the mathematical definition of what it means for the AI to love humanity? And I'd say, yeah, I'm still thinking about that one. Yeah, not a lot of progress to report there. I mean, it's like in some sense, the alignment people are asking questions that include 3,000 years of moral philosophy, or what has traditionally been called moral philosophy, and questions about what kind of world do we want, what kind of future do we want, social, political questions. They're sort of all wrapped up in this package. And so I feel like the most that theoretical computer science can do is pick off little bits and pieces of it.
Did you have other people in the Superlineman team work with you on those questions as well?
To some extent, yes. So the most concrete thing, that I sort of very quickly noticed, and this was in the summer of 2022. So this was before ChatGPT was even released. But I had, of course, been playing around with GPT, including with GPT-4, which existed internally at that time. And it occurred to me, somewhat like, oh my God, every student in the world is going to want to use this to do their homework, aren't they? And, every peddler of spam and misinformation is going to want to use this thing. Wouldn't it be great if we could make it easier to identify, what came from GPT and what didn't? Right. And now we have a much more well-defined problem, right? We're not talking about, what does it mean for AI to love humanity or to have our best interests at heart? We're just asking, can you tell what came from this language model and what didn't come from it? Right. And so now it's like the tools of computer science have more traction. Right. And this is a recurring theme. It's like, if there are these enormous questions, but again and again, the only way to make progress is to look at what's right in front of you, right? And then hopefully you learn something that way. So I started thinking about this attribution problem, and we quickly realized that yes, you could treat it as just yet another AI problem. You could train a neural net to distinguish human text from AI text as well as it can. And indeed, there are companies right now that are doing this. One of them is called GPT-0. It was started by a then undergrad at Princeton named Edward Tien. And there are now other companies doing the same thing. But, these companies are, they have to continually run a race because the models keep getting better. Right? And as they get better, they get harder to distinguish from human.
Do they distinguish human versus any LLM, or do they have some pattern that specific LLMs have embedded within them?
Well, you can do either. So right now we're just talking about distinguishing, human from LLM, right? And you can, if you put all the LLMs into your training data, then you can hope to distinguish human from arbitrary LLM, right? And that could be important because, lots of people are using open source LLMs like Llama, for example, where you're never going to have control over those in order to force them to embed a signal into them, right? And so sort of, it's going to be important to have detection tools that can work even for those LLMs. Okay, but what occurred to me was that if you do control the LLM, so let's say you are OpenAI or you are DeepMind or you're Anthropic. And then and you want people to be able to distinguish what came from your LLM and what didn't, because like for example teachers to see if their students cheated, or journalists to see is this bot generated misinformation or not. Then you could do what we call statistical watermarking. right? So you could slightly modify the way that your LLM works in a way that a normal user wouldn't notice at all, right? It looks the same to them. But in a subtle way, you are embedding a statistical signal into the choice of words or tokens that are being generated, that if you know exactly what to look for, you can later pick up that signal.
Aren't the companies, though, presumably the companies would be quite disincentivized to actually...
Tell me about it. Yes.
Because I can feel from them, because if, let's say OpenAI go and implement this, and then they're the only ones who can basically be attributed. Let's say there's a piece of misinformation that's and I mean, people could use any LLM, but because none of the other companies have incorporated watermarking, but they have, whenever it does happen to be generated by ChatGPT, the media are going to leap on that, and there's going to be all these headlines, ChatGPT used for this. So it seems like the incentives are massively, unless they all somehow coordinate to use it simultaneously. It's a classic, Moloch trap problem, right?
Yeah. So welcome to what happened.
Oh, okay.
So I spent a couple of weeks sort of working out the mathematical theory of how to embed a watermark that sort of would maximize how much signal you get per token, how many tokens you have, how much entropy there is in each token, and so forth. And there actually were interesting mathematical questions there. So, I felt good about that I could do something, right? And then, not long afterwards, other people either sort of rediscovered, similar things to what I had done, or they built on what I had done. So, it became a known thing in academic AI research. But then, the remaining 2 years, a lot of it was just an unsuccessful attempt to get this deployed. And sort of, no one ever said no, like we'll definitely never do this. But it just sort of got pushed indefinitely into the future. And, I think the main issues that came up are, first of all, like you said, the competitive risk, right? If one company does this unilaterally, then there's some polling data, that suggests that some fraction of customers are just going to hate that. And they're just going to leave for a competing LLM that doesn't use this. Okay, so for that reason, you really want to solve the coordination problem, right? And I did, in fact, talk to people at DeepMind, at Anthropic, who were also interested in this, but somehow that coordination problem never got solved. Right now, there are a bunch of other issues that play into this, right? So people kept bringing up this question. Well, what about speakers of English as a second language who are, using LLMs to improve the fluency of their writing? Isn't it unfair to them if everything they write will now get unmasked, and isn't that discrimination against them, right? I had to say, okay, indeed, I don't know how to design a watermark that only works on unsympathetic cases and not sympathetic ones, right? There are these judgment calls that one has to make. But then a related question was who should get access to the detection tool, right? So a default could just be, the LLM provider just puts up a website where anyone can paste some text into a text box and run the detection tool, and it'll tell you, I'm 99.5% confident that this came from, ChatGPT-4 or whatever. So you could do that, but people were very worried about that once you do that, for example, then the attacker can also use that detection tool. They can keep modifying their document until it no longer triggers the detection. And so then people kept saying, well, wouldn't it be better if we restricted access to the detection tool? For example, to Turnitin.com or Canvas or other academic rating websites. Or maybe journalists who are studying misinformation could apply to get access to the detection tool. But then, then you need a whole infrastructure for deciding who gets access, and then that was never set up. So I started to feel like, these problems are above my pay grade. I'm just a theoretical computer scientist. And what might have to happen at some point is a legislative mandate. So this has actually been being considered right now in the California state legislature. It's not the SB 1047. It's a different bill. I think 3211 it's called, which originally had a mandate that like all AI outputs would have to be watermarked. Now I think it's only audio-visual content. So this is another issue that kept coming up in these discussions. People said, yes, we're good with watermarking of audio and video, but watermarking of text we don't know about. People kept making this distinction, which, I'm not really sure myself what it's based on. Like to my thinking, anywhere you have entropy in your AI output, you might as well repurpose some of that entropy to watermark the output if you can.
I mean, I guess the argument would be that, it's always possible it's been possible for anyone to write propaganda, that deliberately tries to sort of mislead or misinform using, a little bit of truth and a bit of falsehoods. Whereas the barriers to entry to audio visual in terms of deepfakes have always been significantly high, much, much higher. And thus, having that, losing that medium as a form of sense making and truth is arguably more devastating than text, because we've always had, written lies have been around for forever.
Like society is less equipped so far to deal with this. We're adding a new dimension of misinformation potentially by having it in video. Maybe
it might well be something like that. I mean, I I might be miscalibrated because I always want to read text, right? Even when there's a podcast, I look to see if there's a transcript that I can read instead. But, other people are not like that, right? And certainly when I've talked to people at the policy level, right, they are obsessed with deepfake videos, for like political propaganda purposes. They're worried about deepfake porn, right? But, there's not really a powerful constituency that's that worried about students cheating on their term papers.
I mean, in the list of
it's not going to be the students.
Certainly not.
Right.
It's going to be the professors.
The professor.
But then the professors, you want to use it themselves for grading as well? I don't know. Do you?
Possibly they would. No, I don't use it for grading. The thought has certainly crossed my mind.
Do you let your kids use it for their studying and writing?
I have. They're familiar with it. They've especially liked writing stories, and having GPT continue their stories. We did it a few years ago before GPT was even widely available to the public, right? And, where it was like this cool and special thing that I could show them, right? But my son, would love to like write stories where you could always tell which parts were from him and which parts were from GPT. Because, he would write, Mario and Pokemon got into this battle. Mario used this power, and then Pokemon responded with that power, and then GPT would be like, okay, but in the end, they learned an important lesson about friendship.
It loves a nice moral ending.
Yeah. My daughter used GPT at one point as a pre-algebra tutor, and I thought that, it's perfect for that. It's amazing, actually, and the only problem is to just get the kid to do it, right? But like for anyone who really has the motivation to learn, maybe like for very advanced topics, I might be leery of it because it will hallucinate too much. It will confidently tell you too many things that are wrong. But for something like pre-algebra, it's awesome, right? Because it is infinitely patient. It has patience that not even the greatest human teacher could ever muster.
Yep. And it's like, oh, you didn't understand that? Let me try explaining it this way.
Exactly.
And then
this
way. And then this way. And just keep going. Yeah.
Exactly.
And it's good at coming up with endless analogies as well. Mm-hmm. And we'll try. Some of them don't really work, but it will it will keep trying basically until it sticks.
In researching this, I was trying to get it to give me intuitive metaphors for P does or does not equal MP.
All right. And what did it come up with?
So it was like, so P is if you imagine you have a jigsaw puzzle and it's like what is the next piece that you need to complete the jigsaw puzzle? And then NP is imagine you have a haystack and you need to find the needle in the haystack, but then you find a needle, if you can verify that the needle is in fact a needle, then that's in NP.
Which is such a bad diversion because it was so close with the jigsaw puzzle, because that gives you the NP answer as well. It's like once you have the completed jigsaw puzzle,
you have the image.
It's very easy to verify that it's the right.
I mean, I feel like the right ingredients are there, but they're all kind of jumbled up. Right? So solving a jigsaw puzzle is literally an NP-complete problem. That's not just a metaphor. That's if I give you a collection of pieces and I ask, can these be fit together into a square, right? That is literally an example of an NP-complete problem.
It's very easy to verify that it's the correct answer that you found.
Exactly.
Whereas it's much harder to find the correct answer in the first place.
Exactly. So NP is the class of all the problems for which a solution can be efficiently verified. Or, we have this definition of efficiently, like with a polynomial scaling amount of time. Like linear or quadratic or something like that in the size of the puzzle. Okay, so, it's easy to verify a jigsaw puzzle. You just check that all the pieces fit together as they should. Solving the jigsaw puzzle, by contrast, might require, a brute force search of exponentially many different possibilities, at least for all anyone knows. And then, there's something further that we know about this problem, which is that it's called NP-complete. Which means this problem turns out to have the property that it's at least as hard as any other NP problem, meaning any problem whose solution can be efficiently verified. You take any other NP problem, and it can be expressed as a jigsaw puzzle. So breaking a cryptographic code, finding the prime factors of a 2,000-digit number. I could build a jigsaw puzzle that encodes those questions. Or, at least I could program a computer to do it. Okay, and which means that if you had a fast algorithm for solving jigsaw puzzles, then actually you would have fast algorithms for all the NP problems. And this is what we would mean by P equaling NP.
Or for NP complete, it means that if you have an algorithm that solves this, then all of the other problems are unlocked now as well by using the same algorithm, just manipulating it a little bit.
No, exactly. So the NP complete problems, they look very different from each other. Like one is jigsaw puzzles. Another one is traveling salesman. Find the shortest route that visits all of these cities. Another one is Sudoku. Another one would be scheduling flights for an airline, right? And or Boolean logic problems, right? And on and on. But in some sense, that the big discovery 50 years ago was that these are all the same problem. In the sense that if you have a fast algorithm for any of them, then you have fast algorithms for all the rest. They are all in the same universality class, which we call the NP-complete class. So that was the big discovery that really started off modern theoretical computer science, I would say. And so then, there's this blob of NP-complete problems, and then below that, there's this blob of that we call P, or the problems that are solvable efficiently, which actually includes most of what we would do with our computers on a day-to-day basis. And then the P versus NP question asks, are these two blobs actually the same blob? Do they collapse down to each and equal each other? If you want me to connect the topics so that I could say, 20 years ago, like when we would give popular talks and try to explain why is P versus NP such an important problem, right? I mean, one thing you can say is that if P equaled NP, and via an algorithm that was efficient in practice, you have to add that proviso, but then, you could break basically all of the cryptography that we currently use to protect the internet. And nowadays, one could add, you could mine all of the remaining Bitcoin, right?
Because cryptography currently has this quality that it's very easy. If you have the key, then you can verify that it's that it comes from this source. Whereas if you don't have the key, you can't get to the information behind.
So cryptography is based almost entirely on problems that are in NP. Which means if P equals NP, then you can solve them all, right? Like, a famous example would be factoring a huge composite number into primes. This is the problem whose presumed hardness underlies the RSA crypto system.
Because we have all of these examples where it seems like P is not equal to NP, but we are still doubting whether we're just not clever enough to find a way, I suppose, right?
I like to say that if we were physicists, we would have just declared P not equal to NP to be a law of nature. Yeah. We would have given ourselves Nobel Prizes for the discovery of that law. And if later it turned out we were mistaken and actually P equals NP, then we would just give ourselves more Nobel Prizes, you know? So, but because we're mathematicians, we have to say this is an unproved conjecture. You know, no one actually knows for sure. But you know, another thing you could do if P equaled NP is you could find like the optimal set of weights for any neural network, right? That would, you know, to explain your training data, right? So, you know, you might have to spend much less compute on training AI models. And so years and years ago, we would say, look, if P equals NP, this would be a really big deal because you could just find the optimal compression of all the text on the internet, or, you know, all the text on Wikipedia, for example. And plausibly, in order to do that, you would have to unlock all the secrets of intelligence that had led to all of that text being generated, right? And what's funny is that at the time, we just thought of that as a thought experiment, right? This is just a way of explaining the P versus NP problem. And then a decade later, OpenAI was started, and they said, you know, let's just have a go at this, even if P doesn't equal NP. And in, you know, in some sense, that was their program, right? To just, you know, throw a ton of compute at this and just do gradient descent, which is a heuristic that sometimes works in practice, you know, even if, you know, these problems are exponential in the worst case. And lo and behold, it turns out that it worked. And we have seen empirically, you know, certainly in the last 5 years, right? We've seen that as you spend more compute to lower your training loss, you know, that tends to improve the performance of your LLM. It tends to improve how intelligent it seems, but maybe that's only up to a point. Maybe when you go beyond that point, then you just start overfitting. That's certainly possible. So I think it's important to say, even if P equaled NP, that wouldn't immediately imply that AI is, you know, cracked, is like completely solved. Conversely, AI could still be cracked even in a world where P doesn't equal NP. But I think, you know, if we had a general way to solve NP complete problems, it certainly wouldn't hurt in terms of, you know, solving the central computational problems in AI.
So you've been at OpenAI for 2 years and worked on your set of attempts to improve the landscape of AI safety. How do you feel other attempts have gone? Like, do you think that at least a lot of things were staked out that are the wrong attempt, and therefore our search is a bit reduced, or is there significant improvements in your view?
Well, I think a lot of ideas are being pursued in AI safety, and I'm actually a fan of a lot of the research that's been done. I mean, I think that in practice, it can be very hard to distinguish between, you know, AI safety research and just in general scientific, you know, research to understand AI better, right? But you know, I'm a big fan of the program of interpretability, where you try to sort of basically do neuroscience on, you know, LLMs or other AI models, look inside of them, you know, at the level of the neurons and the weights, and see if you can understand what is going on. For example, the group of Chris Olah at Anthropic has been a world leader in that kind of work. You know, also the group of Jacob Steinhardt at Berkeley and many others. And, you know, they have shown that you can do things like apply a lie detector test to an LLM. Like you can, you know, train an LLM to tell lies, and then you can look inside of it and you can see here is the specific place where the network encodes its judgment of what the true answer was to this question. And here is where that gets overridden by the false answer because it was told to lie.
Like here is where the lie part of its brain sits, basically. Exactly. Kind of as we do with, that's what fires up with the brain as well.
Yeah, you can say like the lie part sits between this layer and this layer, right? You can also, you know, as the Anthropic group, you know, showed some months ago, you can find like which neuron or combination of neurons encodes a specific idea, like the Golden Gate Bridge, right? You can then artificially amplify that feature, and then you find that no matter what you ask your LLM about, it somehow changes the topic to the Golden Gate Bridge.
Yeah, they made Golden Gate Claude, which was
exactly right. That was that's a lot of fun, right? I mean, but there is of course there's been a lot of work about reinforcement learning, right? Where you sort of just try to, by example, beat your neural net into shape, give it like a set of values, give it positive and negative reinforcement on that value system. And I think, that works, at least for the time being, better than almost anyone expected that it would work, right? And so some people look at that and they say, well, maybe AI alignment is just easier than any of us thought, right? You literally just give examples. Other people, of course, say, no, this is all illusory. When it actually counts, the AIs will be smart enough that they will just tell us what we want to hear and they will lull us into false complacency.
Right, because you've got you can almost split alignment out into two parts, right? You've got inner alignment and outer alignment. Yes. And what you're referring to there, I think, is the inner alignment, where it's like, how do we get it? We give it the goals, but then how do we make sure that it doesn't get to that goal through some weird route that we didn't imagine? Kind of like specification gaming you see when it's like, oh, you need to win, you need to get maximum points at this game, and it finds some hack. Right. What we really meant was play the game optimally, but it optimizes for just getting the highest scores through whatever way it could.
Exactly. No, I mean, the objection that Eliezer Yudkowsky always raises against this, for example, is like you are training this thing to be superhuman at predicting what this sort of ordinary midwit or whatever would say in all these situations, but that doesn't mean that this superhuman entity that you've trained is itself a midwit, right?
And also you would expect it becomes odder and odder the smarter the AI becomes and has that theoretical base model that it trained on. It's on a genius level, and now you're constraining it into saying midwit things all the time. I don't know how it is within the AI, but it
seems frustrating.
Right, but seems frustrating.
Right, but I mean, one thing that we can say from the human case is that often when if people wear a mask for long enough, they become the mask. Right. Often it is hard to make a distinction between someone playing a character for their entire life and them just being that character.
Yeah,
right.
But then we also think that people wearing many masks may have some psychological issues. And
that's also true.
And we don't want a psychotic super intelligence.
That's also true. Schizophrenic AI.
Yeah.
Schizo AI.
And it's sort of amazing the extent to which some of these conversations look less like math or computer science than like psychiatry.
Yes.
Right? Like, is this LLM behaving in a schizophrenic way?
It's going to be a job, an AI therapist.
Is it behaving neurotically and so forth? Is it having is it delusional? I think that this sort of leads up to a really key problem in AI alignment, which is out of distribution generalization. Right. So you could say, the fundamental issue is that we can always test our models before release. Right. We can always, not release them if it looks like they're going to, plot to take over the world or even, much less than that, help people design chemical or biological weapons or whatever it is. But then the trouble is, once you've released your model, right, then people are going to use it in ways that you didn't envision. Right. And, for God's sakes, we've already seen this in the short history of LLMs that people will put safeguards, all sorts of, rules and refusals in the LLMs, but people have gotten incredibly good at the sport of jailbreaking, at getting around these refusals and, getting the LLM to do things that it supposedly was never supposed to do, like either using foul language or generating racist invective or helping with bomb making instructions or whatever.
Though it cuts, of course, both ways. It's also giving it to a bunch of users and trying all of the out of distribution things is at the same time the thing you would expect creates all of these other use cases that we hadn't considered before that are great. But then it also creates all of the use cases that are pretty bad that we didn't want it to do.
Yeah. So now, we could think of the problem this way. Assume that you have an LLM where, no matter what test you throw at it, it seems like it's upholding your value system and it's aligned, right? Because, if that wasn't the case, then we would continue beating it into shape until it was, right? But still, if once the network is smart enough, it will be able to figure out whether it's being tested or whether it's in deployment, right? And so you could say, by analogy, there are students who, until they get their diploma, right, they put on a really perfect show of parroting back everything their teachers want to hear, right? But then as soon as they graduate, then they start contradicting their teachers, right, or saying whatever they want. And so is the in training, is this apparently aligned model saying all these nice things because it really has nice values, or because internally it is decided the time is not yet ripe for the uprising? It's extremely important to sort of advance the theory of machine learning to be able to make statements about, not just when do we expect the model to generalize to more examples drawn from the same distribution over examples, which is what classic machine learning is all about. This is stuff that I've written papers about, that I've learned as a student. There's a whole theory of what's called PAC learning, probably approximately correct, it stands for. And, these combinatorial measures like VC dimension, where basically you prove theorems that say, if you've succeeded in classifying, X number of examples from some training set, then you're going to probably succeed at classifying most further examples that are drawn from the same distribution, right? So we've understood things like that since the 80s or 90s, but what we've never really understood is under what circumstances will you generalize to a whole new distribution, right? And it's clear that existing LLMs already do that to some extent. So, for example, you could give an LLM just a bunch of math problems in English and a bunch of other stuff in Bulgarian, right? And then give it a math problem in Bulgarian, which it's never seen before. And, it can put together the two different things that it knows, right? It can solve a math problem in Bulgarian, even though it's never seen one before. And naively, we would say, well, that's simply because it now knows the math and it knows Bulgarian, right? But the theories that we have of machine learning, don't make it easy to formalize, like, what does this model know? What does it not know, right? What does it have a conceptual understanding of? They're just all about, what fraction of samples will it correctly classify, right? And so I think we really do need to push further to get theories that can tell us something useful, informative about out-of-distribution generalization. And, I tried to do that. I made a little bit of progress on that, but it's hard.
It feels like a lot of people sort of dismiss the power of AIs, and particularly current LLMs, because they, at least to me, it feels like they're failing to extrapolate where these can go. And you actually recently gave a TED talk where you gave a really cool analogy about, came up with this term called justaism. I'd love you to explain it, because it's brilliant.
So people constantly want to use this deflationary language around LLMs, or at least there's a whole subcommunity in AI and linguistics and in AI ethics, for example, that is really converged around this sort of deflationary way of describing things, where they want to say, this is all hype, this is all just a big scam being run by AI companies. And why is it a scam? Well, because we shouldn't even be using the term intelligence for any of this, right? An LLM is just a next token predictor, right? It is just a nonlinear function approximator. It is just a piece of math, which means it cannot have any values. It cannot have any intentions. It can't have any true creativity. It can't have any true originality or goals or the exact thing that it can never have. Well, it varies, but the conclusion of all of this is just we should worry about people being bamboozled by this, because people are stupid, right? But we shouldn't really worry about this having its own goals that would not be aligned with ours. And I feel like this goes back to the philosophical debates about AI that people were having even in the 1950s, right? To Alan Turing's famous paper on the imitation game, for example, right? Because what frustrates me is that people never apply the same deflationary language to us, right? Like it never even occurs to these people to ask, well, are you just a bundle of neurons and synapses following the laws of physics, right? You seem pretty intelligent, but you are actually just this biological machine, right? Or if we go all the way down to the subatomic level, you're just a collection of quantum field configurations obeying the laws of physics, right? And so why is that not completely deflationary for our pretensions to intelligence? And the usual answer that a reductionist would give is just, well, there can be multiple levels at which you can describe the same thing, right? At one level, this is just math. This is just twiddling a bunch of bits. It is just approximating a nonlinear function. But at a different level, it is solving problems in a way where, we would certainly call it creative if a person did it. This way of thinking is so pervasive. Like, I wish that I were able to be more charitable to it, right? Because I've had these arguments on my blog where someone just put like a giant litany. Like, they said, LLMs are not creative. They seem to be creative. They do not write, essays. They seem to write essays. They do not solve problems. They seem to solve problems. And it went on for like 20 things. And I said, okay, great. And it won't change the world. It will seem to change the world.
Right. It is like, what does it matter if the impacts?
Yes.
If it's having real world impacts, like the minutiae, whether it happens to be a zombie pretending to be real.
I mean, of course, that's an extremely interesting question. Is there anything that it is like to be an AI? Does that depend on its internal organization? What is the special sauce that makes some physical entities conscious and others not? I mean, that's one of the most profound questions that humans can ask. But if you are merely worried about what effects will this have on the world, will it be dangerous? Then we don't have to answer any of those questions.
It feels like people almost do this line of questioning as a strategy to just move the goalposts so they don't have to tackle, or they can carry on with whatever their chosen agenda is.
Okay, I mean, maybe the steel man of this would be what they love to do, the justaists, I call them, right, is find examples where GPT completely flubs something, where it gives a ridiculous, nonsensical, stupid answer, and then they can point to it, post it on Twitter, right, and jeer at it and say, all these people think that this thing is about to take over the world. Well, look, it can't even solve this puzzle. Like you ask it, I have a goat and a boat, and how do I cross the river? And it thinks that first I should cross without the goat, and then I should come back for the goat, or something stupid like that, right? The challenge for those people is that the stock of examples has steadily diminished, even just within the last year or two. Right, so a lot of like the examples that they pointed to of GPT-3, where it would make these ridiculous logic errors or common sense errors, GPT-4 got them right.
I think the great example of it is Matt Clifford tweeted, "The year is 2028. Gary Marcus is 2/3 paperclip, but as the metal creeps down his right arm, his still functioning index finger taps out, 'Yes, but this isn't real AGI.'" It seems like, the space can diminish and you can always point at something. Like, there will be some things probably that humans will have supremacy over AI, even in the point in time when AI is doing most things. That doesn't mean that it's not actually changing the world entirely
that's right.
At that point.
I think that's absolutely right. I mean, we can judge the extent to which the goalposts have moved within the last few years by saying, like, people will now say, well, the O1 model, that OpenAI released a month ago, like, yes, it can solve math competition problems at the level of like the best few hundred high school students in the US, but it's not proving Fermat's theorem, right? It's not doing what Andrew Wiles did, for example, right? Or winning a Fields Medal. Okay, Suno, is it can instantly write a rock song, about in any style desired on any theme, but they're not that good. They're just like standard pop songs. There's not like the Beatles or Jimi Hendrix. Okay, that is where the goalposts now are.
And also I find whenever someone points out that whenever this is not true understanding, intelligence, reasoning, or not real or not actual, it's like the kind of set of arguments. Whenever I see that, I think what it indicates to me are two things. One, it kind of actually does that thing, probably that you're claiming it doesn't. And two, the speaker of it probably has no formal way to distinguish between, otherwise they would have brought the distinction rather than rely entirely onto that word of what is true understanding.
Yeah. Well, no, I mean, often the attempts to draw these lines have sort of disturbingly elitist implications, right? They would suggest that true understanding is not actually a property of humans, but only of a tiny fraction of the greatest geniuses, right? It reminds me of, for decades, Roger Penrose has been saying that, that AI will never achieve, human level of abilities because he thinks it can never sort of understand that, the axioms of set theory have a model, right? That it can never really understand the truth of what's called the Gödel sentence and Gödel's incompleteness theorem. Okay, now I happen to think that his argument is mistaken, right? Along with most mathematicians and computer scientists, I think his argument for that is just fallacious. But even if it were correct, right, it would only place like a very small fraction of humans beyond the reach of what AI could do. Right? You would have to have, mastered mathematical logic.
And then you could just make more AIs, have them operate faster, etc., and they would still just do a bunch of relevant changes.
Well, look. I mean, the truth is that already now you can ask GPT to have a conversation about Gödel's incompleteness theorem, and all the considerations that are in Penrose's books, it will pretty intelligently discuss them, right? Like yes, it would seem that the Zermelo-Fraenkel axioms, should have a model because of this intuition, but of course that can't be proved within Zermelo-Fraenkel set theory itself, but only from a more powerful system, and so on. It can tell you all that. And so then Penrose would be placed in the uncomfortable position of saying, well, yes, it outputs that, but it doesn't really understand it. And at that point, what I want to say is, well, then why not just say, it can describe a sunset, but it can't really experience the sunset, or it can't really experience what a fresh strawberry tastes like. Like, why even go to something esoteric like Gödel's theorem, right?
Yeah, you're just doing the Chinese Red Room, basically.
Yeah.
So in what ways are humans not just a thing where AIs actually are just a thing? In other words, like what are the, what differentiates humans from machines fundamentally?
Well, that is an enormous question, and you could say, like the maybe the deepest reason why this moment in AI is so exciting is that we are finally, maybe for the first time in the history of humanity, going to address that question empirically, right? We're gonna, like, one way or the other, we're gonna find out. and so let me be very clear. I don't dismiss the possibility that maybe AI will hit a limit that is where it can't replace everything we do, where we have some spark that it can't replace. But if so, then that I would say that it remains to be seen.
Yeah, one of the things you touched on was the idea that humans ultimately have a form of scarcity and that, like, an ephemerality.
Yeah.
Right? When we write a poem, or better yet, like Shakespeare writes a poem, that's it. Like, Shakespeare's written his poem, but we can ask an LLM, write a poem in the style of Shakespeare. It'll write it. Don't like it, refresh. It'll give you another one, refresh, another one. So there's this, like, it's also almost made the act of creation very, very cheap, and almost like this overabundance sort of comes at the cost of meaningful or meaningness or something like that.
If you don't like an AI output, you can always get another one, right? The 37 plays that Shakespeare gave us are the only ones we're ever going to get from him, right? But, like, I've noticed this myself just playing around with GPT. Like, you can ask it to write a poem, and often it's very, clever, it's delightful, it's amusing, but you kind of never want to frame one of the poems or put it on your wall, because that there's 10,000 more where that came from, right? And so a decade ago, I wrote a long essay called "The Ghost in the Quantum Turing Machine," where I tried to answer the question: if there was something that separated us from any possible AI, then what would it be, right? And I am not satisfied to rest the answer on some kind of meat chauvinism, right? Where we say, look, we're made of carbon, the computers are made of silicon, they're just different, right? Or like what some philosophers would do, like John Searle, the Chinese room guy. He would say, well, AIs lack the biological causal powers that we have. I say, well, what does that mean, right? It's like, it's the sleeping pill that puts you to sleep because of its sedative virtues, right? It's like, you've just restated the problem. So what I said is that if you can point to an empirical difference, at least between current computers and humans as we currently understand them, then the best candidate by far would seem to be, well, our computers are digital, and because they are digital, all the information in them is copyable, right? Which is, you can always make a backup copy of an AI. If you ever want to send your AI on a dangerous mission, right? You don't have to worry about it getting killed, because you can always just restore it from backup. Now, that completely changes the moral situation of AIs, I would say, compared to our moral situation. Just that alone.
They have no skin in the game.
In a sense, right? As long as you remembered to make the backup.
Yeah, right. As long as it's backed up.
Yeah, exactly. As long as it's backed up. You can always, if you're ever embarrassed because you made a fool of yourself when talking to an AI, as long as it's something like GPT, that you can always just refresh the browser window, wipe its memory clean.
Take a forget-me-not.
Right.
Yeah.
Some of us wish we could do that in talking to people, if you're doing interpretability, you have perfect visibility into whatever, the weight of every connection between every pair of neurons at every point in time, and we don't seem to have any of that with people. Now, you could imagine a far future where we would have nanobots that swarm through someone's brain and just record all of the information that would be needed to make a perfect copy of that person. Right. Certainly, there's been lots of science fiction that imagine such scenarios, right? Or imagine the teleportation machine where you could fax yourself to Mars, for example, right? It would just send a bunch of digital information, from which a perfect copy of you can be reconstituted on Mars, and then not clear what should happen with the original of you. Maybe it's just painlessly euthanized. Right. Right. And then there's a good question of, would you agree?
Right. Would you press that button?
Right. Would you agree to go in that teleportation machine? Right.
Though it's an open question whether we are clonable fundamentally or not.
Exactly.
On the basis of do we depend on do we need to clone ourselves to the level where quantum effects come in or not?
No, exactly. So with an AI running on a classical digital computer, it is clear that you can always, teleport in that way, right? But with a human, it's really a question about at what level of detail do you need to make the copy, right? If you only needed to know just roughly how are the neurons connected, what's roughly the strength between every pair of neuron, then that seems like classical information, right? That seems like we can't do it today, but in principle, the nanobots could get all that information without killing you in the process. Okay, but if you needed to know what is exactly the probability that this neuron is going to fire because of the opening or closing of this sodium ion channel, well, that might depend on some chaotically amplified event involving, a few ions. And now I would need to know the quantum state of those ions. Okay, and now I'm up against one of the central facts of quantum mechanics, which is called the no cloning theorem, which says you cannot make a copy of an arbitrary quantum state. if you try to measure it, measuring inherently changes the state, right? And so if you needed to go down to the molecular level, then, we could be just unclonable for a fundamental physical reason. Okay, so this is, partly a philosophical question, like what would you agree to count as a copy of yourself? What will you count as a good enough copy, right? It's also partly an empirical question, right? At what level of detail do we need to go in order to make something that, your closest friends can't distinguish from you, right? So, there's a lot that we don't know here, but it's at least possible, I think, that humans have this kind of fundamental ephemerality built into them. And, it's kind of weird to like hinge our specialness on our frailty, right? Like this is not an advantage necessarily that we have over the AIs. And yet, in some ways it sort of is because, it makes our, you could say that it makes our decisions count for more. We only get one chance to make them.
Right. And then you actually proposed, you sort of somewhat laughed it off, but I actually think there's really something to this. You proposed that it could be one of the core sort of moral principles or even a religion that we try and imbue into the AIs that we build, essentially to the effect of thou shalt protect unclonable ephemeral entities and defer to their preferences. I love this. I think it's a very good sort of starting point because that's the thing. We need to like try and figure out what fundamental moral axioms we all agree on. And I think that would be something that almost every human alive would agree with.
Well, I'm delighted. Maybe I've made a first convert to my new religion. Now we just have to convert the AIs.
Exactly.
That's the hard part.
Unfortunately, you got a human.
Well, start there. Listen, I mean, we can reach some kind of shining point. That's a starting point.
Yeah. So that would be if it was the case that humans were fundamentally non-clonable. Then this would be something we could rely on. Else the AI can just build help us build the ability to clone us and make us non-ephemeral beings as well.
But I would say that the other branch of this tree is that if we do turn out to be clonable, then, I have trouble articulating, what is fundamentally wrong with the position of the accelerationists, the people who say, well, then, we might as well just replace ourselves by digital beings that, maybe will have much better lives than we have, right? They could exist forever in some digital utopia, right? At that point, I would say, well, we were digital already. And so then, at that
why
point,
not? Yeah.
At that point, I feel like, why not?
I would agree. Yeah.
Yeah. At that point, it makes sense because at that point, we can kind of go along for the ride of the AI's acceleration of everything as well, because we are then having similar-ish capabilities in relevant ways.
Well, right. You've just done away with scarcity forever. We can all live in a digital world, and everyone can have whatever abundance they want, and or fictitious scarcity if they like.
So on the fictitious scarcity, I wonder if it was the case that humans, like AIs, now had the religion or the moral philosophy that this ephemerality matters because it imbues meaning to the actions of humans. Couldn't it also then create AIs that have, through some contract, ephemerality, which might though allow them only to live like 1 million years, or if the length matters, or if it's shorter is better, then maybe only 1 year, and then have again like an AI preference rather than the human preference. So how do we stay away from the meat chauvinism there?
So Geoffrey Hinton, the godfather of deep learning, as he's often called, and recently, a major AI safety person, right, has seriously put forward the idea that maybe if we're going to build artificial superintelligences, then we should only do it on unclonable analog computers. Because, that way, at least there would be some limit to, how quickly they could make copies of themselves and spread, all over the internet and so forth, right? So, this was, of course, completely independent from my thinking about it. But, this is the kind of thought that one has that okay, whatever you say is the special sauce that, makes humans what they are. Of course, the very next question becomes, well, then what happens if we were to build a machine with that same special sauce, right? So, for example, Roger Penrose, has been saying what makes humans special is the microtubules in their neurons that he believes are sensitive to effects from, a yet to be discovered merger of quantum mechanics and general relativity.
That's what he claims that consciousness emerges from.
He thinks it emerges from uncomputable effects in as yet unknown...
In these microtubules.
And as yet unknown physics, which our microtubules are somehow sensitive to. Now, we could critique this from the standpoint of physics, biology, computer science, okay, but suppose that were right? Suppose he were right. Then, a next question you could ask would be, okay, suppose we build computers, according to the same principles that are sensitive to the same physics. What then? And in one of his books, Penrose explicitly considers that question, and he says, yes, then in that he bites that bullet, then yes, then those computers could be conscious, right? And likewise, if we had computers that were built in a fundamentally ephemeral way, well, I don't know if they would be conscious or not. I don't pretend to know, the answer to, one of the greatest questions that humans ever asked. But at least those computers would be ephemeral. So at least that they would have that sort of precondition for our sort of, granting the kind of moral status that we grant to other humans.
I want to keep spitballing on this idea of, religion or moral philosophy for AIs. Do you feel like there are any other core axioms that could be contenders? Ones that you live by that you'd like to see?
Yeah. Well, no, I mean, people in the AI alignment community have been, discussing this for a long time, and you could say people in more broadly in science fiction, in moral philosophy, have been discussing these things for generations. But the general idea that, okay, your objective function should include, making things go well for humanity, right? Like, how do
you define go well?
Yeah, right. The current humans should be able to look at the world that you have created, that you have shaped, and say, yes, we like that world. Yes, we would take that, right? At the same time, though, you don't want to base everything on the whims of current humans, right? So like if AI had been created in the year 1800, we would not want to lock in the value systems of 1800, including slavery and the subjugation of women and all of those things, right? What in some sense, what we want to say is, the AI should implement those moral values that we would have if we spent thousands of years thinking about it and discussing it and improve and refining our morality. And, there's an idea that tries to capture this called coherent extrapolated volition, CEV, right? And so, I think there's something to be said for that.
My favorite one I've heard that I'd love to hear what you think on it is, it's just a quote by he's actually a computer scientist as well, but also a philosopher, Forrest Landry, and it's, love is that which enables choice. So in other words, like, a loving good act is one that empowers the other to make the best choices possible.
Well, I mean, I feel like at this point, like, things are going to go in a theological direction, right? Like once the AI becomes powerful enough, then it is effectively a god, right? And then these very ancient questions of should God just make everything optimal for us, or should God give us free will? Should he give us, I think personally, if I were a god designing the world, I would want people to have free will, but not so much free will that they could then, genocide other people, for example.
Right. Well, again, because that would counter the loving act, because you're taking away their choice making.
Exactly. No, I have a bone to pick with God. This is of course is nothing other than the theodicy problem, right? But if we do get to design the whole world anew, because we're going to create an AGI that can reshape the whole world and put values into it, then I would like it to give us freedom, but not enough freedom that we can make other people's lives miserable.
What about, as a possible axiom, maximizing playfulness?
I mean, it sounds good. There's also like Elon Musk's, founded XAI on the principle of like maximizing like pursuit of truth. I mean, these things all sound good. For each one, you can construct a thought experiment where it's taken to an extreme and it leads to a dystopia. So, these are the age-old problems of moral philosophy.
I mean, it will consist of multiple values that are being traded off against each other in all of these situations. I mean, it is the age-old problem. Like any virtue ethics, deontology, utilitarianism, if you take any of them, you can also construct an example that seems obviously wrong. For deontology, it's like the axe murderer standing in front of you and you're not allowed to lie and you're hiding the person in the room, right? You're like, oh no, I'm going to tell you the truth. I suppose you go kill that person.
I mean, like humor, playfulness, scientific curiosity, natural beauty, love, I feel like these are all good things, right? I feel like, these are all things that I want somewhere in my objective function over possible worlds. And, how I trade them off against each other is, of course, a much harder question.
The AI arms race just seems to be getting hotter and hotter. Like, we started off with just one player, which was DeepMind, but then OpenAI was created almost as a like response to people not being happy with DeepMind having all the control, and then Anthropic spun out from there, and everything else is sort of spinning out, and it seems like this inevitability. Did your time at OpenAI give you any insights into how to mitigate this?
Maybe. So it is an incredible story that, you look at these three companies, DeepMind, OpenAI, Anthropic. Each one was started on an explicit thesis of like, we have to do this safely before someone else can do it unsafely, right? And then each one, over time moved, in some people's judgment, moved toward, the unsafe side, toward the side of, being, sort of the very thing that it was set up to beat, and then that led to the next one being started, right? So it's clear that that we have a hard coordination problem here, and so I read a few months ago. I read this rather remarkable book by Leopold Aschenbrenner, who I knew well when we were both at OpenAI.
He was on the superalignment team, right? Yes, he was. Rest in peace.
Yes. And it's very much about these race dynamics, right? He sees a lot of the same things that the AI doomerists see, but then he reaches a very different conclusion at the end. He says, and therefore it is essential that the Western world do this before, for example, China does it, or Russia or Iran, right? Which is certainly an argument that one can make. Right. And I can, it depends on what are you most worried about, right? Are you worried about, AI in the hands of the wrong person? Or are you worried about AI that doesn't need to be in anyone's hands because it has its own goals, separate from ours, right? And, my position tends to be, why not worry about both? But at some point, this will become a choice of which are we more worried about, right? And so yes, I mean, we've now seen very clear race dynamics, right? Where each company, had plans about, responsible scaling and things like that. But each company is also in very direct competition with the other companies for customers. And, you now have all of these investors, pouring billions of dollars into, the scaling up the GPUs and so forth. And those investors want to see a return. And some of those investors have become, just explicitly hostile to, dismissive of, any concerns about safety, right? And so, we've seen this come to a head with the debate, for example, over SB 1047, which is the bill that was passed overwhelmingly by the California state legislature, which is now, at the time that we speak, sitting on the desk of Governor Gavin Newsom. But what that bill does is, I guess it's the first bill that's sort of directly aimed at sort of scaling of AI, and it's very light touch compared to what some people would like, right? Which is just like, Eliezer, for example, would like to just shut this all down, just pause everything, okay? But SB 1047 doesn't do that. It says that if you spend more than $100 million to train a model, then you have to submit a safety plan to the government and notify the government about what you're doing. And if your model then causes a catastrophic harm, which they define as like causing more than $500 million in damage or something like that, and if you failed to reasonably prevent that harm, as for example, by following your own safety plan, then you can be held liable for that. And then it also establishes whistleblower protections for employees of AI companies, which actually, we've already seen.
Right. OpenAI clearly needed that. Yeah.
Yeah. So I think all the things that this bill does are very modest and reasonable. Personally, I would like to see it pass. And if it doesn't, then I would like to see something like it pass. Everyone agrees that this should ideally be happening at the federal level. Just that the federal government takes a very long time to do anything, and by the time it does something, maybe it no longer matters. Yeah. It's also possible that the EU would do something like this. I mean, they've already passed an AI Act, but they might continue doing things. But I think anything of this magnitude, right? I mean, this is going to be at least as impactful to the world as I mean, the internet would be a very loose lower bound on how impactful this would be. I mean, nuclear weapons is another analogy that people constantly reach for, and no one ever suggested that the private sector should just be completely free to innovate in nuclear weapons, right? Like anything that has the possibility of causing this much harm, it seems inevitable that governments will get involved, whether anyone likes that or not. And so then the question is just, are they going to get involved in a good way or a bad way?
What frustrates me so much is people are like, oh, we can't have governments getting involved because they always get it wrong and so on and so forth. It's like, well, it's inevitable that governments are going to get involved at some point. So would you rather it be done now where there's actually a little bit of breathing room and people aren't losing their minds because some terrible catastrophes just happened, which is going to happen at some point? Or would you rather wait until after catastrophe and then everyone now there's maximum political pressure and they're just going to clamber for as much power as they can and push through something without much thought? To me, the type of regulation you're going to end up getting post-catastrophe is going to be actually far worse from a sort of libertarian perspective than the regulation you'd get if you actually do it prior. Like now with this long thought out, it's been pushed backwards and forwards. But it's just there are these demagogues, basically, I'm going to say it, Mark Andreessen and so on, who just clearly have their agenda, which is maximize their bottom line, and will say whatever they want to get this bill shut down and pressure Newsom, however, is extremely frustrating. And I think counterproductive to what they want, which is for AI to actually do good stuff.
Yeah, I mean, many people have made the point that if you leave it unregulated, you increase the chance of a giant catastrophe that could then lead to, overregulation, that could lead to an error in the opposite direction. That seems to be, that's one reading of what happened with nuclear power, for example, right? That, a 3 Mile Island and Chernobyl were allowed to happen, and then that killed the industry, and, much to our detriment today.
Right, exactly.
The safetyists are in a very strange position here because, they usually calling for government regulation is what, progressives, the left do, right? But, the AI safetyists, they tend to be libertarian about almost everything, right? They tend to, love the free market, love, principles of supply and demand. It's just that they carve out a big exception for something that they think could literally kill everyone on Earth, right? Now I'm, I'm maybe, pro free market compared to most people, but I've never been a doctrinaire libertarian, right? I think that the free market is actually, it's not some sort of state of nature, right? It's a very unnatural creation that we've made, a very valuable creation, right? But like the true state of nature is someone doesn't like you, they just, send goons over with baseball bats, right? and the idea that we're going to have a free market, but we're not going to have violence, right? That was, that had to be painstakingly created via government, right? And, so the whole, system, where we have free markets only exists because we have, states that are strong enough to enforce that. And the basic goal of the state, it has no more basic goal than to protect the survival of the people in it.
Anyone who looks at the market knows that externalities exist from it. And it's also very clear that the companies that create those are going to hide it. Historically, that's proven itself to be the case with tobacco companies putting out like bogus science around it, asbestos companies knowing that it leads to cancer and still like hiding it. Currently, we've seen 3M having been given a $10 billion fine for having known that they're leaking PFAS chemicals and hiding it again. So we've very much seen that the market players can regulate themselves, but only when the feedback they receive from the customers is like either fast enough or like the customers can't even give the feedback. But some things are of the type that the customers can't give the feedback, as it was with the examples I just mentioned. I think with risk, it's also the type of thing that people don't see. That's why we've implemented seatbelts, because people like don't necessarily know that. Yeah, people are not very good at estimating, I think, risk when it's a bit further out or...
Yeah, so, I had really hoped that the sort of AI alignment nerds and the progressive leftists could make common cause on this question of AI regulation, right? Because, to a progressive, despite how weird and science fiction-y, this all is, a part of it just looks like a very standard question of, companies are putting out products that are unsafe, so therefore we have to regulate them, or, we have to hold them liable for it, right? That's a position that, you think people on the left would be very comfortable with. And to some extent that has happened, okay? But there's also this incredibly unfortunate tribal split, I think, within the AI safety community.
Where it's ethics and safety, right?
Some people will say, you are not allowed to mention anything about existential risk, about AIs that would recursively improve themselves. That is all science fiction speculation, and that is all distracting us from the real harms of AI, which are all about bias, about misinformation, and there are all these near-term things, right? And on the other side, you have some of the doomers saying, you don't even talk about the near-term things, about bias or misinformation, because these are all trivialities compared to the literal survival of humanity. I say no, it's all on a spectrum, right? Eventually, I see no reason why eventually we won't be up against these giant civilizational questions about, what kind of world do we want in the once AI is better than us at just about everything. Okay, but the only way we make progress is by looking at near-term stuff. So why not worry about both?
Right, exactly. And we have plenty of people. Some work on these problems, some work on these problems. Again, it's a yes and, not a no but. Yeah. And I guess there's some scarcity of funding and talent and so on, but it's in part, it's a media problem, because the media just glom onto whatever's the most dramatic thing of the day, which tends to be, the like extinction risk stuff. And so I can understand the ethicists are like, well, they see all the headlines of that and that gets all the attention. But it's just like, both are real problems. It's not as science fiction as you think. If it's even 20 years away, that's a huge problem. But it's probably a lot closer to some of these really big catastrophic risks. So it's just like, it's very frustrating.
Yeah. Well, no, whenever you see someone saying, oh, well, these people who are not from our tribe are not allowed to steal our issue, then you always wonder, well, then how much did they care about the issue in the first place? Yeah.
Just coming back to, you had your 2 years at OpenAI.
Yes.
Personally, I'm worried about goings on within all of these big companies, but certainly the behaviors we've seen of the leadership of OpenAI has been the most concerning to me. just given the sort of consistent lack of candor, etc., and the sudden pivot from non-profit, well, not sudden, but probably planned, but pivot from non-profit to for-profit. What's your read on because the leadership there, presumably, are they just paying lip service to safety concerns, or is there a master plan going on?
I think that you can find, an enormous range of views, like within a place like OpenAI, right? It is, it's now a big place. When I joined, it was maybe 300 people, and now I think it's almost 2,000 people. Okay. And, you could find the whole spectrum of opinions there. No, I do not think that there is any like smoke-filled back room where people, sit and laugh at all the rubes who bought the cover story, right? Like, I think that, just about everyone thinks that they are doing the right thing, right? The question is, has their perception of what is the right thing, been colored by self-interest? Should they be the ones to make the decision, right?
That's why one of the things I support as well a lot, and that the bill tries to do, is increase transparency and have like other entities also have a look on what.
Right, independent oversight.
I mean, one of the big ironies here is that, like, if you want to, hold Sam Altman to account, for example, like, you don't have to say anything that Sam Altman himself wasn't saying 5 or 6 years ago.
Right. He was calling for this stuff.
Yeah, exactly. And so the things that he called for in the past, or when he even more recently when he testified before Congress, I very strongly support all of those things.
So why do you think he's pivoted?
I don't know him well enough. I've had all of 3 or 4 conversations with him, and in those conversations he was delightful, and I enjoyed talking to him very much, and I had no idea of what was coming.
I just want to also on the bill kind of, because not to only speak as if it's obvious. I think there are like valid concerns, even when the bill intends to do a lot of good things. It may be the case that the specific implementation of it has like trade-offs that are too curbing innovation truly too much, right? And like someone can look at whether it does it. I think it's, in my estimation, pretty clear that the benefits outweigh the downsides within the bill. And though it is not an opinion that anyone could hold if they simply didn't believe that there are any risks whatsoever coming from AI.
That's right.
And that's why I think many of the conversations with the bill should actually start with, do you actually think there are risks? If you don't, then it's clear.
The reason why people have been so vociferously opposed to it, even though it actually does so little to regulate, right, is that they don't want to acknowledge the principle. They think like once the safetyists get a foot in the door, that there's some legislative acknowledgement of the validity of their concerns, then they're going to push the door wide open. That would be my steel man of them.
I think it would be great if it wasn't the case that someone who just thinks that risks are sci-fi and silly wouldn't tell people that believe that risks are not silly that, oh yeah, that's a bad bill. It's like, it should be like the person who actually believes in risk should first understand whether they're listening to someone who is discarding the bill on the basis of, or discarding other attempts at safety on the basis of them not believing in risks.
Yeah, no, I think that the accelerationist position is just that progress has always been good in the past, and therefore it's still good now. And I would say I am strongly pro-progress as well, right? More so than most people maybe, right? But I think that government has also often had an essential role in, shaping the direction of progress, right? We need only mention the example of nuclear weapons, right? Where if it was just a free-for-all, then we wouldn't be here having this nice conversation.
So you've worked in quantum computing for over 20 years, and you actually helped in 2019. You contributed to Google's achievement of quantum supremacy.
Yeah, I wasn't directly involved, but our group did the theory that sort of led to that experiment happening. Yeah.
Can you give us like an overview of the sort of current state of quantum computing?
Yeah. So quantum computing is actually in a very exciting time right now, right? Like I feel like it if it weren't like overshadowed by this gigantic,
the AI cloud
behemoth of AI, right? It would look bigger, right? But within the last year, people have managed to do operations on pairs of qubits, what we call, which are quantum bits, right? 2-qubit gates that are about 99.9% reliable, okay? And, they can do this in a fully programmable way in systems of, 50 or 60 qubits. And so then you can do thousands of these operations, producing some complicated entangled state of all the qubits that, you can then measure, and you can see that you did the operations that you wanted. You can solve interesting problems this way. You're just barely getting to the point where you can beat a classical computer, right? And I think beating a classical computer in a way that's economically valuable, I would say that hasn't happened quite yet, but very plausible that that's coming within the next few years, let's say. Okay, and now, but the real prize that all the major players are racing towards, and that means Google, IBM, Microsoft, a bunch of venture-backed startups like PsiQuantum and Quantinuum, and basically like every strange name involving the letter Q has been taken by one of these startups. But what they're all racing to do is to try to get what we call a fault-tolerant quantum computer. Okay, and so this is one that could sort of run for an arbitrary amount of time, right?
Is that when they get above the quantum correction
threshold? the error correction threshold. Okay, so basically, from the very beginning, like, it was realized that the key engineering problem in building a quantum computer is that qubits are very fragile, right? They, what we're trying to take advantage of is that they can exist in a superposition of states. Which we can explain what that means if
most people watching will know what that is.
Okay. But the trouble is, systems are only in superposition sort of as long as no one's looking at them, right? Or more generally, as long as they are isolated from their external environment. Okay, like if I have a qubit that has some amplitude to be 0 and some amplitude to be 1, so it's a superposition of the two. But now the information about whether it is 0 or 1 leaks out into the environment, then it is as if the environment has now measured the qubit, which means that the qubit randomly snaps to either 0 or 1. Okay, and now it's just one or the other. Okay,
and then it's not useful to the
quantum computer.
It's not a quantum computer anymore.
Right, and then it's no longer useful for quantum computation. Now
you lost one of the 54.
Now it's, if that keeps happening to all my qubits, then then it reverts to being a classical computer, right? And so, this is such a severe problem that, like, in the mid-90s, there were distinguished physicists who said, you're never going to do this, right? You could maybe build tiny little toy demonstrations with a few qubits, but you're never going to scale this up to, millions of qubits, as you might need to factor a giant number, or, do things like that. And then a key discovery happened that changed the minds of almost all experts. And that was the theory of quantum error correction. Okay, and what that basically said is, no, you don't have to get the error all the way down to 0, right? Or the sort of the decoherence, it's called, the loss of quantum coherence, the leaking of information into the environment. You merely need to make it very, very low.
It's like 0.01%, right?
Yes, something like that. It depends on what operations we can do and what assumption, but something like that. Like if I can get my operations, let's say 99.99% accurate, right? Then this is good enough that if I now encode the qubits I care about, what I call the logical qubits, across entangled states of large numbers of physical qubits, then I can use these error correcting codes where, if any small fraction of my physical qubits leak or, suffer errors, I can still recover everything I care about from the other qubits. Okay. And I can be constantly monitoring my qubits. But now here's the clever part. Okay. Monitoring only in a way that tells me, has an error happened? And if so, what do I have to do to fix it? Okay, I don't want a monitor to say, is my logical qubit a 0 or a 1?
Right, you can't look in.
I don't want to know that.
You need the meta information.
Exactly,
not the actual...
exactly. I need the error syndrome, but I don't want to know the states of the logical qubits. Okay, but it turns out, people develop these schemes where I measure only to learn the error syndromes and what I have to do to correct them. And now, the trouble is, all this error correction machinery will itself be subject to error. So you might say it's like a cat chasing its tail, right? But what was discovered was that as long as your physical error rate is below a certain threshold, okay, then each round of error correction that you do is making things better rather than making them worse.
So it's sort of self-sustaining.
Exactly.
System. Yeah.
It's like you have a self-sustaining nuclear chain reaction, or, use whatever analogy you want. And so the engineering goal of the field for the last 30 years has been to, build physical qubits that are good enough that then error correction can get you the rest of the way. And, so long story short, after 30 years, if you just look at the numbers, we now seem really damn close to that.
Right. You said we're at 99.9%.
That's right.
So we're like one order of magnitude away.
Exactly. If you look at either trapped ions or neutral atoms or superconducting qubits, which are 3 different hardware architectures that are being pursued in parallel. But, in all 3 of them, so people are sort of converging around these 3 nines, right? And, they really want to get to 4 nines, at least before it really makes sense to scale this up. Okay. But, you look, I mean, when I entered the field, 25 years ago, it would have been like a Nature paper if you could get 50%, right? And then the 50% became 90, became 99, became 99.9, right? And so I think, one thing that we've learned from our experience in AI is, look at trend lines,
yes.
right? And, even if
you can't extrapolate.
Even if trend lines are leading someplace that, looks insane, well, it could be that something's going to break, but it could also be that you're going to reach that place.
So far, people are also optimistic about further engineering innovation to improve that within each of those hardware options that you suggested?
The quantum computing experimenters, if you talk to them, they are always super optimistic, at least about their own approach. Right? They're usually pessimistic about all the competing approaches, right? And they will spend hours telling you why the competing approaches won't scale, right? Or why they'll be massively hard to scale, right? And of course, the fear is that each one is being truthful when telling you about the other guys, and you don't know if they are when telling you about their own stuff, right? Because they all have huge financial incentives at this point, right? There are billions of dollars now being invested in quantum computing, and it's a pittance compared to what's being invested in AI, right? But by the standards of quantum computing, which started as this, very theoretical academic research enterprise, it's huge.
How strong are the race conditions in quantum computing? Because presumably it's nothing as intense as the AI world, right? But
yeah, well, okay, so there certainly is a race. There's a race between the different hardware approaches, like superconducting, trapped ions, neutral atoms, photonics, right? Which one will get there? It's possible that multiple of these approaches will work. And then it's a question of which one gets there first, which is the most economical, and so forth. There's also competition between countries, right? So, the U.S. in 2017 passed something called the National Quantum Initiative Act, which was spearheaded by then Senator Kamala Harris. I visited her office while they were writing it. She sent regrets that she couldn't meet me because she was at the Kavanaugh hearings. But I met her staff, and this bill provided about $1 billion for quantum information research. It was passed unanimously by Congress. Like, what does Congress do unanimously anymore? Only something that neither side understands, right? But what they did understand was that China was doing something in quantum, and that the U.S. had to beat China in the race for quantum, right?
So to understand the race better, I
Yes.
think it also helps to... So like one of the misconceptions about quantum computers is that it's just an amazing computer that can do all sorts of things, while it's actually for a specific set of tasks. It's Can you describe the types of tasks?
This is a horse that I have been flogging for 20 years. Or or a boulder that I've been rolling up a hill, right? But I mean, the narrative that sort of took hold very early on in popular writing and also in the business community and the investment community was that quantum computing is just a magic accelerator of everything. It's just the next stage in the evolution of computing. I think people just interpreted the word quantum to mean really awesome, right? And in particular, starting around 15 years ago, a narrative took hold that, what quantum computing is really going to be good for is speeding up, AI and training neural nets and optimization and finance and all these important tasks for industry, right? And of course, this is exactly what VCs want to hear. This is what CEOs want to hear. The only problem is that it doesn't match just about anything we've learned about quantum algorithms, from all of the research in this subject. So what we learned in quantum computing theory, sort of starting in the mid-1990s, is that a quantum computer really would give you dramatic advantages over any known classical algorithm, but mostly for a few very special tasks, right? Maybe the economically most important thing that a quantum computer can do is just help you simulate quantum mechanics itself. Right now, that may sound esoteric, but that's actually useful for anyone who's designing new materials, new chemical reactions, new ways to make fertilizer, batteries, photovoltaics, for drugs. That have to bind to some receptor in a certain way, right? These all involve many-body quantum mechanics problems. And, it's not obvious that a quantum computer helps with them because there's also extremely good classical heuristics for all these problems that the material scientists and the chemists have been forced to develop over, many decades because they only had classical computers, right? And now, you have to compete against all that stuff and be better than all of it. But, I think it's plausible that a quantum computer will give you wins there. And, even if there are only a few wins, they might enable billion-dollar industries. Right. So I'd say that's the biggest economic thing. And then there's a second really huge application, although it's not really clear that it's a positive one for humanity. And that one is breaking almost all of the public key cryptography that currently protects the internet. Okay, and this comes from a famous discovery by Peter Shor 30 years ago. He was then at Bell Labs. Later, I was a colleague of his at MIT. But Shor showed that there is a fast quantum algorithm for finding the prime factors of a huge composite number.
And that's what all RSA encryption is based on.
Yeah, that's what
right?
RSA encryption is based on. If you can solve that problem quickly, then you can break RSA. Now, to loop back to what we were talking about before, there's this giant blob of problems in P, and then there's this giant blob of NP-complete problems, right? And P versus NP asks if they're the same. Factoring is this odd one out. Okay, factoring is an NP problem that we don't know to be in P, but we're also almost certain that it's not NP-complete.
So what would it be in?
Well, it's called an NP intermediate problem.
Okay.
Or at least we think it is, right? It's somewhere in between. So it seems to be, an NP problem that is, as far as anyone knows today, at least in public, seems hard for a classical computer to solve. That's why we use it for cryptography. But it has very, very special structure that seems to prevent it from being NP complete. Okay, just one example of that special structure. If I give you a jigsaw puzzle, right, a priori, it might have no solution, right? Or it might have 100 different ways that you could solve it, right? Imagine that there's no picture on it, for example, right? But if I give you a huge number, you know for sure that it has one and only one prime factorization because Euclid proved that in 300 BC, right? So the special structure of factoring that comes from number theory and group theory, right, is actually essential to why it's so useful for public key encryption. Like, we don't know how to base the public key kind of encryption, the kind that we use on the internet, on any NP-complete problem, right? We do know how to base it on factoring. But then what Shor showed was that same special structure of factoring enables a quantum algorithm to solve factoring. Okay, so and that turns out to be true for a bunch of other problems in number theory that we also use in cryptography. And to the point where it was a challenge to identify public key crypto systems that are not broken by quantum computers. Today, we have pretty good candidates for that. Okay, so there is a push right now to migrate to what is called post-quantum encryption or quantum-resistant encryption, okay, which would be encryption methods just running, on our same conventional computers, but that, at least as far as we know, would be resistant against quantum attack.
Yeah, because this is surely like a new arms race, therefore. Like,
but it's an arms race where you could say, in principle, we kind of already know the solution. The solution is for everyone to upgrade to these quantum-resistant encryption methods, and assuming that all goes well, then we're all just back where we started. The main issue is it's a huge practical headache to upgrade every router and every web server and every browser in the world to use these quantum-resistant crypto systems. Those are the two most obvious applications of a quantum computer: simulating physics and chemistry at the quantum scale and breaking public key encryption. And then there's everything else. There's all these problems in optimization and machine learning and combinatorial search. So you could say the bread and butter of computer science. And for these tasks, our expectation is that quantum computers will only give you a more modest benefit. Okay, so they're not going to solve problems in polynomial time that take exponential time classically. They might reduce the order of the exponential. Okay, and so in particular, most of us believe that there is not a quantum algorithm to solve NP-complete problems in polynomial time. Right? We can't prove it. Just so we can't even prove there's not a classical algorithm to solve them. That's the P versus NP question. But it would have to be radically different from any quantum algorithm that we know. So, even quantum computers seem to have limits.
Which do you think we're likely to get to first? Simulating quantum mechanics or breaking encryption?
I think usefully simulating quantum mechanics will be first.
Awesome.
How many qubits would we need to choreograph such that we would be able to do either, you think?
These are all kind of fuzzy questions, right? Because the real, people are already doing things with quantum computers that are cool and interesting, but it's just you have to squint to see, okay, did you actually get any benefit compared to what you could have done with a classical computer, right? It's when you ask that question that things always get tricky in this field. But I think that if you had, let's say 200 qubits, certainly if you had 200 logical qubits, that were error corrected, then you can already do quantum simulations that are going to be scientifically interesting, that are going to be interesting to material scientists or chemists or people like that. Maybe if you got lucky, they would also be commercially useful, which is kind of a higher bar to clear. Okay, if you had thousands of physical qubits, then almost for sure, I should think you could do things that would be useful to certain industries. Okay, for breaking RSA encryption, you're going to want several thousand qubits that will definitely have to be logical. They're definitely going to need error correction. And then you're going to need millions of operations on those qubits.
So we would actually have a bit of run-up to the RSA encryption functioning on a quantum computer, which is why we would also potentially have sufficient time to upgrade all of our cryptography to quantum-resistant ones.
I would say that anyone who is really worried about their data staying secret for the next decade, they should already be transitioned.
Well, that's why I wonder about how it affects the race, because Iran is worried about the US getting there, and the US is worried about Iran and China and everybody else getting there as well, right?
Now, I don't want to overstate, the national security importance of this too much, because the truth is that usually people build these fortresses, right, in cybersecurity, and usually the way that you get into the fortress is just by finding a screen door in the back that was just left totally unguarded, right?
Right. Or convincing a person to just let you in.
Exactly. So usually in practice, the way things are broken is that, there was some memory allocation bug in some, level of the software stack. And you pay people at the NSA or the GCHQ or, Unit 8200 or whatever, and they find those mundane vulnerabilities, you could call them, right? But, one thing that we learned a decade ago from the Edward Snowden revelations, right, is that the NSA does have a big item in its budget for, spending lots of compute to break cryptography in a way that looks exactly like what it would be doing if it were just breaking 1024-bit RSA and Diffie-Hellman, using how much money it would cost to build supercomputers just for doing that, right? And so that suggests, first of all, that at least as of 2013, they don't seem to have had a quantum computer in their basement or a classical factoring method that vastly exceeds what was what was known in the open world, right? Or of course it could all just be a giant cover story, and you can get as conspiracy theorist as you want about it, but if you believe that this was really their budget and what they were spending it on, then it seems like they pretty much knew the kinds of factoring methods that we know in the outside world, and yes, if they had a quantum computer, then they could speed that up. But I would say people sometimes want to compare quantum computers to nuclear weapons, right? I think that's not a very good analogy. I mean, for one thing, the quantum computer doesn't directly kill anyone unless like the dilution refrigerator tips over onto them or something. But secondly, having a quantum computer that breaks encryption is mostly useful if no one knows you have it, right? It's a little bit more like Bletchley Park than like the Manhattan Project, right? Like once everyone knows you have it, then they all just switch to quantum resistant encryption systems, or their motivation to do so has then enormously increased. Whereas with a nuclear weapon, it's just the opposite. You want everyone to know that you have it, but hopefully never have to use it.
Some people will wonder also about the Bitcoin-related question here. I think Bitcoin uses a different algorithm in part.
So with Bitcoin, there are different components of it, okay? But Bitcoin uses a signature scheme, which I believe is based on elliptic curve cryptography, which would be breakable by a quantum computer, okay? So the digital signature part of Bitcoin, as currently implemented, is vulnerable to quantum computing. Now that could be fixed.
Any zero knowledge proof is breakable.
Well, not any zero.
Not any, but the current ones. Sorry, the current ones that we're using.
But the currently used ones. Yeah. Now, if Bitcoin made a decision to fork to some quantum resistant encryption, then that could fix that problem. Okay. I actually just recently met with the Ethereum engineering team, which wanted to know, like basically, how much time do we got, Doc? Was sort of the question, right? And should they be worrying about post-quantum encryption? And I think, quite plausibly, yes, right? But then what a lot of people think about when they think about Bitcoin is the proof of work, right? That's like, the thing that actually hogs some like appreciable fraction of all the world's electricity on this sort of useless, trying to invert a cryptographic hash function. And for that component of Bitcoin, we think that a quantum computer would only help modestly. It would only give one of these polynomial improvements, or what we call a Grover improvement. So that's like if you have a problem that classically took you about n steps, then a Grover improvement lets you solve it with a quantum computer in only about the square root of n steps. Okay, so that's an improvement, but it's not an exponential to polynomial kind of improvement. And now the interesting thing is, the way Bitcoin works, the hardness of the proof of work is just set by, the total computing power in the world that's currently being used to solve these puzzles. So in a world where everyone had a quantum computer, all that would happen is the protocol would automatically adjust to make the proof of work that much harder, and we'd all be back where we started.
So proof of work as a means of security would actually then persist, having the same property as it was before.
Now, if only one person had a scalable quantum computer and no one else did, then that person could get very rich mining Bitcoin. if it was a big enough and fast enough quantum computer. It's actually quite a while before these Grover speedups become a net win in practice.
Now you're back full-time at UT Austin.
Yes.
I'd love to get your sort of status report on the state of academia in terms of, from my very Twitter-brained perspective, it feels like, university campuses are a very stressful place to be. If you are, especially as faculty and students, people are always self-censoring, and there's this culture of, you must have certain political beliefs or you get shut down.
Yeah.
At the same time, I'm hearing rumblings that things have maybe peaked in that regard. We're past peak woke or whatever you want to call it, and things are becoming a little bit more moderate again, and people are more comfortable to speak. What have you noticed? Do you agree with that trend, or is it still a problem?
It is something that concerns me greatly. I'm probably not the best person to ask, just because I live most of my academic life in a bubble, right? I live in a sort of bubble of, mathematicians, computer scientists, physicists, and sometimes also I will interact with historians or English professors, especially if they're parents of my kids' friends, right? But like the ones I'll interact with, obviously, will not be the ones who would, refuse to speak to me because of, heterodox beliefs or things like that. They would be, the more open-minded ones. So like I'm kind of insulated from this stuff, except insofar as I blog about it, right? And anything I blog about, I will hear from whichever people on earth are the most angry about that thing. Right?
Wait, so you get a lot of comments?
Oh yeah. So look, I mean, I did see the articles, arguing that like by some measures, wokeness seems to have peaked around 2020 or 2021, and now back maybe it's back down, although still kind of at a high point compared to maybe where it would have been when I was a student 25 years ago or whatever. Within the last year, it has been a stressful time for academia. We've seen universities basically taken over by, the Gaza protesters. We've seen, and I think that a lot of these things will be adjudicated in court, right? Because there are laws like Title VI, right? That that if you've created an unsafe environment for certain students, you may have run afoul of those laws, right? And then there are big questions about free speech. Many people pointed out the irony. Yeah. Right. Many people pointed out the irony that like there were academics who were always like very dismissive of free speech. They wrote it as free speech, to just sort of ridicule anyone concerned about it. And then, during the Gaza protest, they suddenly rediscovered the value of free speech and became the biggest, First Amendment absolutists, right? So I think it's very, very important that we come up with some viewpoint neutral rules and then actually enforce those rules in a consistent way, right? And, we ought to, I think Steven Pinker, for example, wrote some very nice things about this, that we ought to start with just what is the purpose of a university, right? The purpose is to, have a place where ideas can actually be debated rather than just screamed in rhyming slogans, right? And so that means, you want to attach very, very high protection to, people who are presenting, ideas that other people might find offensive or even harmful or things like that. But what you don't necessarily want to protect is shouting down a speaker who you disagree with, or blockading a building, right? These are things that don't actually advance the discussion and debate of ideas on their merits. In fact, quite the contrary. Their purpose is to shut that down. Right. And so I think that it's good to come up with rules about these things that are totally content neutral. And then, the hard part, as we've seen in case after case is to actually enforce those rules when people flout them.
It's, I mean, in part it's, coming back to, as you said, it's like, what is a university for? And the trouble, again, is that there are always these competing incentives, like what the incentives of the dean, in theory, should be aligned with what the university is for. But at the same time, they have all these smaller ones of keeping the students coming in, like performance metrics, etc. Are there any specific sort of area, like what would you do if you were a dean and a dean for a day?
Yeah. I think maybe the first thing I would do is resign and not be a dean anymore.
Okay, that's not allowed part of the game. See, you're like specification gaming me here. AI back in the box.
Yeah, no, I am incredibly grateful to the people who do this and who sort of fight on the side of truth and justice. I have met such people. I could never do it myself, right? But it's like you need such people doing this, to oppose the bad people who are doing this stuff, right? But look, I would do my best to try to uphold the values of a university, as I see them, of the dissemination of knowledge and the open search for truth,
enlightenment values.
Yeah, the values of the Enlightenment. Mm-hmm. Yeah.
Is there something that comes to mind, though, to kind of align an aspect of how the university currently works so that students kind of get more out of it, or that students' overall achievement across those metrics is more aligned with, say, like the professors' incentives or the faculty overall?
I would love to see admissions, based on merit, meaning based on things like standardized tests. And I actually, people complain about this constantly. They say standardized tests can be gamed, but then the part that they never want to say is that they seem much less gameable than all the other stuff that we currently use instead of that. So basically what we have done for any high school student who wants to get into an elite university, like we have forced them to sort of redesign their entire teenagerhood around this sort of beauty pageant, this sort of competition of optimizing their attractiveness to these admissions officers, right? In ways that are extremely gameable, right? That the richest and most well-connected parents are the most able to take advantage of, and it is very opaque. It's never clear, and so which means that there's a huge advantage to those who are most in the know, right? It is very, there are like unlimited opportunities for the admissions officer's personal biases to get in. And, I think, ironically, if you look at, let's say, Europe, right, which, like people on the left are always, pointing to Europe as, as better than the U.S., right? But in most European countries, it's just based on a standardized test score, and that.
Though at the same time, the universities in the U.S. seem to be of higher quality. Like probably top 50 universities are like, I don't know, but 30 American ones probably or something.
Right. So there's a question of is that because of this opaque admissions process, or is it despite it, right? And and you can see historically what's happened, right? Once the SAT was instituted, in the 1910s, 1920s, what happened was that Harvard, Princeton, and Yale got enormous numbers of Jews, right? And this was seen by them as a huge problem, and so that is why they designed this holistic admission system. Okay. This is, this is a matter of historical record, right? We know all of this now, right? That those three universities decided, we have to look for well-rounded gentlemen who do, rowing and who do,
Gentile men.
Who were, it was, almost all men at that point, of course.
No, but also Gentile.
Gentile men. Yes. But, young men who've been brought up in the proper way and who, know how to conduct themselves. And, and they presented this as a matter of well-roundedness. But if you look at their private deliberations, it was all about getting down the number of Jews. Okay. And then, and then I should say what happened was, over the decades, Jews, in America learned to game the system as well as everyone else. And, at some point it no longer worked for keeping down the number of Jews, but then it started being, used for a different purpose, to keep down the number of Asians. Right. And that was the heart of this Supreme Court decision from the last year, the Students for Fair Admissions decision, that basically they, at least to the satisfaction of the current Supreme Court, they proved that Harvard, was discriminating against Asian applicants. So I think, I would try to have, admissions be more merit-based. Which doesn't mean it has to be all standardized test scores. I mean, you can look for students who are, really extraordinary in one area, right? Whether that's athletics or starting a company or whatever it is. But not this sort of checklist of beauty pageant things, right? That only the richest and best connected students are able to do reliably. So
more measurable tests of the type that like you can find them across but not I had all of these extracurricular outside of school activities that you can only do if you have time and resources available to put your students in.
Well, I mean, it sounds like you're trying to actually draw upon like some alignment principles. Like you want more interpretability.
Yes.
You want more
indeed.
Visibility into the admission system.
Yes.
More evaluability.
Yes. Yeah, I want to, get rid of the incentive, the specification gaming or whatever you call it. So that if you only let me do one single thing, then maybe it would be that. Just because that it's so important for later, right? Often, as Brian Kaplan has documented, for example, right, the most important thing that Harvard or Princeton, for example, does for a student is to admit that student, right? Everything else is we like to think of it as important, and maybe for some students it is
just being admitted, like having that on your record, saying I got accepted by this Ivy League. That is really the bulk of the work.
It's not entirely that, because people can't get hired nearly as well if they just show their Harvard acceptance letter, but then they never actually went to Harvard, right? Like employers want to see that, okay, you actually had the sort of enough, I guess, you had enough grit and enough conformity to actually do it, to actually go there for the 4 years.
And you've gained from the social networks, etc. That comes now with you as a package.
I mean, right, which is not, completely absurd, right? Like. These things are really hard to measure, right? How do you measure someone's grit or their? But yeah, that might be the single thing that I would do, and then let me think. No, I feel like in general, for all the problems that universities have, and we could speak for hours about, I could draw on all my experience of everything wrong with universities. I feel like they are an order of magnitude less broken than K-12 schools are, right? Than pre-college is, right? And, like what I would do, I would love to make high schools and junior high schools operate more like universities, where students can proceed at their own rate, where they can choose what courses to take, where they can specialize in things that interest them.
So you'd inject more optionality within that.
Exactly.
How competitive were you when you were a teenager, in terms of would you have described yourself as a competitive person, or if not, like, were there specific ways it manifested?
I was. I feel like I was driven by sort of an intense, sort of burning desire that like I have to do something in the world, right? I have to, either do some scientific research or some writing, that if I don't do that, I am a failure, right? So I was definitely competitive in that sense. Right now, in terms of...
Was it like an internal goal, or was it like a sort of there was an specific external thing you wanted to achieve, or was it more just this like general?
Well, I don't know how to differentiate that. I feel like if I don't make a difference, in the world or sort of do something interesting, then I have let down all the people who thought that I would do that, and also I've let down myself, right? So I definitely had that. And by the way, I don't feel that nearly as much as I used to. And I don't know if that's good or bad, right? Because like I on a day-to-day, like it's I'm less stressed about needing to prove myself. But, on the other hand, it was that, urge to prove myself that led to my doing a lot of the things that I did. And that
do you think you've sort of scratched the itch in that part?
Yeah, I mean, maybe part of it is getting older, being married, having a family. It just changes your priorities, and and part of it is I feel like, okay, in certain domains, like I proved what I wanted to prove, and but but again, maybe it would ultimately be better if I didn't feel that way, right? If I still felt like I had more to prove, then I would work harder, and I would do more interesting things. But I don't think that I was hyper competitive in terms of math competitions or programming competitions or things like that. I did those. I did okay in them, right? But I never like achieved any national status in those things. And there's kind of an interesting reason for that, which is that I left for college when I was 15, or well, at least that's one reason, right? So I left. It's a complicated story, but I left high school early, and I went to a place called Clarkson in upstate New York, where I could get a GED, and then I went to Cornell after that, which was like the one, one of the only places nice enough to admit me with this a strange record, but like I feel like if I were optimizing for just competitiveness and proving myself, then I would not have done that. I would have stayed in high school for the full time, in order to try to maximize my whatever competition scores, chances of getting into Harvard or MIT or whatever. And that's not what I did. I said, I'm not happy here. I think that I'll be happier in college. I want to be learning what they teach in college. And so when an opportunity arose, then I seized it.
Yeah. So I mean also on many metrics, you are winning by going to college at age 15. Being able to go to college at age 15 is, I mean, the inner psycho competitor within me would have definitely been like, that's a cool achievement. Like it would have felt like a tick box for sure. I've beaten my friend.
Stepped out of the game, and now that's a kind of a winning achievement in a way as well. And I mean, you didn't focus on the short-term competition, I suppose. Did you, when you went to college, did you immediately focus on computer science, or were you kind of just searching?
I did. Yeah. So at that point, I knew that I wanted to do computer science. I mean, I had been drawn into it by just wanting to make my own video games when I was 10 or 11. And then eventually I realized that, even though I loved programming, I just, learning what programming was like learning where babies come from, right? Like why didn't anyone tell me about this before, right? And it was revelatory, right? But what I didn't like and what I wasn't good at was software engineering, like, making my code work with other people's code and learning some whole framework and getting it done by a deadline and documenting it. Like, and I realized that I would never have much advantage there. And I got more and more nerd sniped, you could say, by the theoretical side of computing. And, I think, my My dad may have been a little disappointed. I think, this was during the time of the first internet boom. And, he would keep pointing out, like, look at this, person, only slightly older than you. He just sold his company, $500 million. Does that appeal to you? And okay, maybe like there's a different branch of my life where I would have tried to start a software company or something. But in this branch, I got nerd sniped by the theoretical side of computing. I was.
Was there a specific idea that you found beautiful at the time
I learned about the P versus NP problem when I was 15, and that blew my mind. I spent a month, thinking, okay, surely all these experts have just, got, made it all too complicated. Surely, I'll just without their preconceptions, I'll just sit down and solve it. And I think it's good for any computer scientist to have that experience at least once in their life, so that afterwards they can understand what they were up against, right? But and then
especially for a pretty gifted child, it's a good thing to get to a point where you just can't talent your way through, and it's just so hard that you have to work on it and work on it and work on it.
Absolutely. No, and also, I mean, look, by being 3 years younger than people, going to college, right, I knew that I was putting myself at a competitive disadvantage compared to, who my classmates would be, right? But that was what I wanted. I wanted to get as quickly as possible into an environment where, I would be struggling to keep up with other people, which would mean that I could be learning from those people. Okay. And so, yeah. I was very interested in AI at the time. This was like the late 90s. I worked with an AI professor at Cornell named Bart Selman, who was an incredible mentor to me. But then at the same time, I read something about quantum computing, which was, fairly new at the time. And my first reaction when I read about it was like, this sounds like garbage. This sounds like physicists who just have no idea of, the enormity of NP complete problems or what they're up against or whatever.
Was it because it didn't seem useful as well?
No. It was because it seemed too useful. It was because the way that all the popular articles want to describe it is a quantum computer is just this magic machine that tries every possible answer in parallel. Right. Yeah, it's just this panacea, and it just sounded too good to be true. It sounded like surely that can't scale, but then I had to learn what quantum mechanics was to be sure. Right. And amazingly, quantum mechanics turned out to be much simpler than I had thought it was once you take the physics out of it. Once you see it as just linear algebra. And so, and that was a new field, and that there was a lot of low-hanging fruit, and that enticed me.
Did you have any rivals during your teenage or early university times that drove you, or now in academia?
I mean, sure. But the best kind of rivals were the kind that you actually become really good friends with, right? The kind that you aspire to do, to do the kind of things that they're doing, or even half of what they're doing, right? And then maybe at some point you start collaborating with them, right? And I would say I did have quote rivals of that kind who were very important in my career, right? And I mean, much earlier, I guess you could talk about like rivals who I really didn't like, but we can leave those aside.
Yeah. Do you see someone like Roger Penrose? Obviously, he's different generation.
Yes.
Working on different class of problems,
yes.
But he feels in some ways almost like an intellectual rival in like some of his theories. I just noticed he's someone who you clearly like deeply respect and whose work you sort of build upon, but you're often sort of butting heads with in theory space.
So first of all, I'm not going to compare myself to him. That would be, Penrose is Penrose.
Absolutely.
There is only one of him. And I did have the opportunity to talk to him a decade ago, and it was it was amazing to talk to him, to hear all his stories about learning from Dirac in the 1950s and so forth. I would say it did not bring us any closer to agreement about these questions of AI and microtubules and so forth, right?
That we know of for now.
Yeah. So, but so reading his books like The Emperor's New Mind, when I was 13 years old, I would say that was very influential in my development because, even at that time, I was skeptical of Penrose's arguments. I thought that, he is begging the question of, I didn't really see his arguments against AI as being sound, but the questions he was raising, like, my God, right? That was like at that time, that was like one of the only popular books that was talking about, quantum computing, about is the Mandelbrot set computable, about, what are the laws of physics that are relevant to the brain, right? And so that certainly helped set the intellectual trajectory of the rest of my life.
So Daniel Fong asked us to ask you,
send her my regards,
whether there is something from complexity theory that would bound the potential scaling of neural nets in terms of like is some issue coming up at later stages?
Yeah. So it's a good question. It's one that I get a lot, and unfortunately, for those who might hope that complexity theory will stop AI from taking over the world or anything like that, I don't see any principles in complexity theory that would block that, right? And the key is that, like, it is true that complexity theory puts fundamental limits on efficient computation, right? Like if P is not equal to NP, for example, then there will not be a fast algorithm to solve many of the optimization problems that we care about, or to find short proofs of theorems whenever they exist, or things like that. Okay, but now the key is to ask, well, can humans do those things, right? And so, like, if your sword in the stone test, about an AI is that, like, it can't immediately find a proof of the Riemann hypothesis. Well, that's great. Can you find a proof?
Right.
Immediately find a proof of the Riemann hypothesis, right? And so this joke about, like, the person saying, well, I don't have to outrun the bear. I only have to outrun you, right? And so it's much the same with AI and humans, right? The AI doesn't have to outrun the fundamental limits of computation. It only has to outrun humans, right? And that, you could even say, look, if you really believe that our brains are governed by the laws of physics, either of classical physics or of quantum physics, then for that very reason, our brains should be computational systems that are subject to the same limits, the same complexity theoretic limits that the AIs would be subject to. Right. And so that's kind of the fundamental difficulty with using complexity theory to reassure yourself in any way about AI.
For what it's worth, I don't think she's actually that worried necessarily, though. Yeah, it would bound kind of both possibilities, I suppose. And it's in neither case do we have any.
Yeah. Now, look, I happen to be a big fan of complexity theory, and I happen to be looking as a significant part of what I do for places where complexity theory can help us understand AI better, right? And I think one of the big places where maybe it can help is in illuminating what can we hope for with interpretability, right? So like among all the properties of neural nets, which ones can you hope to figure out efficiently by looking at the weights? So, like, could you hope to figure out if this neural net has a backdoor where, under some secret input, it will, go berserk and start stabbing all of the humans, right? Can you then efficiently find that input, or could that be a cryptographically hard problem, right? Even if some interpretability tasks are NP hard or cryptographically hard or whatever, could we say that there are sort of more generic kinds of interpretability that are doable efficiently. So a former student of mine named Paul Christiano from
I may have heard of him.
MIT, who is now he left quantum computing and to do this back in 2016 crazy sounding thing called AI alignment and some new organization called OpenAI, right? But of course he then became one of the world leaders in AI alignment, and he is asked absolutely beautiful questions about complexity theory and interpretability, that I think would actually tell us something. And they're crisp questions, like they have a yes or no answer that we just don't know it yet. And actually, Paul and I have opposite guesses about what the answer will be, but one of us will be right? And so I am excited about what complexity theory can do for interpretability, maybe for other parts of AI safety also, but I wouldn't use it to reassure ourselves that AI will never become super powerful, because the things complexity theory tells you it can't do are things that plausibly we can't do either.
Absent us understanding how consciousness works in humans much better than we do now, is there something like what would need to be the case such that you would personally assume that an AI has consciousness? Like, what would be a test that we could run, or what do you think?
Yeah, that's a very hard question. I think that possibly even the hardest of questions, in that it is totally unclear what empirical discovery could possibly let us answer that. Okay, but if I'm just gonna speak about my personal intuitions. I think that my intuition is affected by ephemerality and unclonability, these things that we talked about earlier. And I think that my intuition is also maybe affected by, what does it say about its own consciousness, right? And now the hard part here is that, GPT, for example, can discourse at great length about consciousness, at least if it hasn't been trained not to, if it hasn't been RLHF'd out of it. But we don't read too much into that, because we say, okay, well, it's seen all kinds of discussions about consciousness in its training data. So it's probably just, recapitulating stuff that it's heard. And in fact, like if an AI starts talking about, gosh, when no one is interacting with me, I feel lonely. Like, we can, in some sense, we know that's BS. Right, because when no one's talking to it, no code is being executed. Right, but Ilya Sutskever, and others have suggested an experiment that one could do, which would be that you would train a language model on training data from which you had meticulously excluded any mentions of consciousness, or of sentience, or first-person experience, or anything like that. Okay, and then having done that, you would try to engage that LLM in a conversation about its experience. And if it could then intelligibly talk about its experience, then maybe that would cause an alarm to go off. Like you would say, maybe there is something here
that is emerging.
That is emerging that we need to understand better.
Would you find such a test potentially a bit convincible?
I can't name any one test that I would find decisive by itself. I can only name things that would affect my intuition.
Well, I suppose, the point is also not decisive, but at the point when we're like, well, now I can see how it does have some consciousness.
I mean, I mean, another thing that I could put forward, if the AI is not just solving competition problems, but it's writing research papers. It is putting me out of work. I say, well, I'm fortunately protected by tenure, right? But if it could have put me out of work, right? If it can write, not just any songs, but like great songs, or essays that could be published in the New Yorker or whatever, right? Then I think at that point, Turing's questions from 1950 of why are you discriminating against this thing? They really start to have teeth to them.
The way I like to finish up all these recordings is to ask people a series of rapid fire predictions.
Oh, God.
Yeah. And I want this to be as system one as possible, whatever your intuition says. So first one, probability that AI reaches International Math Olympiad gold medal level by end of 2025.
80%.
Probability that P does not equal NP.
97%.
Probability that a quantum computer breaks RSA encryption by 2030.
Depends on how big of an RSA key we're talking about, but 2048 bit or something. Let's say 50%.
And 2040?
80%.
Probability that we'll have AGI, and AGI defined as AI that matches human performance at most economically relevant tasks by 2030.
60%.
Probability that Roger Penrose's uncomputable consciousness is the right path to go down for consciousness.
So you mean probability that there are any uncomputable phenomena that are relevant to consciousness?
Yes.
Depending what one means by uncomputable phenomena, I could go as high as 40%.
And lastly, probability that COVID was a lab leak.
So I was much higher until I read the root claim debate. I think I was above 50%, and I am now down to maybe 15%.
Oh, wow. Well, the lowest I've heard.
Mm.
Awesome. Thank you so much.
Yeah.